Hi everyone, welcome back. In this particular video, we will be discussing the problem linked list search. We are given a linked list, that is some linear nodes arranged in form of a singly linked list and a target element X. So given that X, what we have to do is we have to find if there exists a node in the linked list with data equal to X or not. In the entire linked list, is there any node with the data X? If yes, then most probably we have to return true. If not, then we have to return false. And how I am sure? I can read the second line to be sure what the output format is. So input and output both are handled by the main function. We do not have to do anything about the main function. We only have to do what? We only have to implement the function which is given in the uh, code editor. Or you can say we will be given some input as parameters, as arguments, and we have to give the output as a return type from the function. So structure of linked list will again be given to you. You do not have to create a linked list. Already linked list will be given as an input and structure is given in comments most probably. So we do not have to change anything in the structure of the linked list, and also rest of the code should not also be changed. It should be the same. It only and only the function which we have to implement should be added. The lines of code should be added in it. So input format, there will be 3 lines of input containing n number of elements in the linked list or number of nodes. Then n space separated integers containing the nodes of the linked list, and it will automatically form the linked list in the main function. We do not have to do anything. That is, if there are 5 nodes containing value 1, 2, 3, 4, 5, so all of these nodes will be created and the head node of the linked list will be given to us, and the target X is a 2. That is, we have to search whether 2 is present or not. So answer is true. Yes, 2 is true. The target 2 is present. So we have to print true if the target is present, otherwise print false, as we have already discussed. Constraints will be n can range from minimum 1 node, at least there will be at least 1 node in the linked list. Linked list cannot be empty in this constraint according to this constraint, and maximum the number of nodes can go up till 200 in nature. And what is the solution which we are going to propose for linked list search? Do we already know how to search on an array, on maybe a linear array kind of thing, or maybe we can say a dynamic array? The answer is most probably you might have learned various kind of searching algorithms. Like there might be a linear search algorithm, there might be a binary search algorithm. So in this particular problem, I am making a simple linked list with random nodes, with random data actually. So these are all the nodes, and obviously last node will be having the next pointer as null. Let's assume this is node with address 1000, 2000, 3000, 4000, 5000. It means 1000 dot next will be 2000, 2000 dot next will be 3000, and up till 5000 dot next will be null. That is, it will be the last node, the tail node. And obviously we are given the head pointer of the singly linked list as the parameter, as the input parameter. So if I take the target as maybe 50, if I take the target as 50, is 50 present in this linked list? The answer is yes, there is a node with value 50. So what we have to do in this case, we have to print true, or we can say return true. But what if the target is not 50? What if the target is, let's suppose, 45? Is 45 present? No, in the entire linked list, 45 is not present. So in this case, we have to actually print false. Can there be multiple nodes with same data? Yes, there can be. Even if let's suppose this is not 40, even if let's suppose this is 20 only. And if the question is that target is 20, is 20 present? Answer will be of course yes. 20 is not only present, but it is present for multiple number of times. But still answer is true. The question is not right now count the occurrences, it is only just find whether there is occurrence or not. So it does not matter whether a target is present 0 times, in that case it will be false, or 1 time, in that case it will be true, or multiple times, still it will be true. So it doesn't matter whether the elements are duplicate or not, answer will remain same. But the important point is, in arrays, we learned about 2 algorithms as we discussed. Linear search, which will linearly iterate on all the array elements and search which element index is having basically equal to the target value. Or the second approach was, given the array was in sorted order, given the array was in increasing order, we can also apply binary search. But since currently the linked list is given, first of all, there might be a chance that binary search is not possible. But surely what we can say is, since the data is not sorted, it can be in random fashion. There is nothing related to sorted data. So binary search is ruled out completely, because for binary search, the data should be sorted. So only and only one algorithm remains, which is linear search algorithm. So we will be doing a linear search. It means we will be going to each and every node of the linked list and ask whether that node is having the data equal to target or not. So let's just first do the traversal for target 50. What I will do, I will start the traversal from root node, or actually the head node. So head node is the first node of the linked list. So let's say we are traversing using a pointer named as current, starting from head itself. Current will be asking, is current dot data, is it equal to 50 target? No, 10 is not equal to 50. Okay, let's go to the next node. But in array, we used to go to the next node by jumping the index. 0 becomes 1, 1 becomes 2. In case of linked list, we will go to the next node by actually making current is equals to current dot next. That is 1000 dot next, which will become actually 2000. Again, ask the same thing. Is 2000 dot data, that is current dot data, is it equal to the target 50? No. Again, current is equals to current dot next, which is 3000. Is the current dot data is equal to target? Again, no, it is 50. The target is actually 50, but the node is 20. Go to the next node. As soon as I will go to the next node, 4000 dot data or current dot data will be equal to the target 50. So yes, we can say return true. So for the target 50, we were searching and we started from root node or the head node and we went till the fourth node in the linked list. In worst case, what if, let's suppose the last node was 50 or maybe 60 and the target was itself 60. In that case, we have to travel to each and every node because target will be present at last node. Or even if the search is unsuccessful, let's do a try run for search unsuccessful for 45. I will say, is the target equal to the current node data? No. We will start from head node, obviously. Go to the next node. Is 30 equal to target 45? No. Go to the next node. Is current dot data equal to target 45? No. Current dot next. Is 50 equal to 45? No. Current is equals to current dot next. Is 20 equal to 45? No. Current is equals to current dot next. And as soon as the current reaches null, can we say that the linear search is done? We are not able to find the target. So it is a unsuccessful search. So as soon as the target is not found, it means we can just simply return false. And when is target not found? As soon as the current pointer reaches null. In this case, obviously it was successful search. And the try run will be very much similar for multiple elements. Only the case is, as soon as the first occurrence of target is found, 20's first occurrence is found, we will return true, because we do not care whether there are more occurrences of 20 or not in this particular question. So we are actually searching for the first time the target element is appearing in the linked list. What will be the time complexity for this particular question? Since for successful search, worst case we can go till the last node, so order of n, because each and every node traversal will require constant time, but for how many times? N times if there are n number of nodes. And even for the unsuccessful search also, we are going to each and every node jumping by one position. So that will also be linear. What about the space complexity? Will we require any extra space to solve this problem? Will there be any auxiliary data structure? Actually, no. Only input traversal is required. So input data structure is already created. We will not include the space used by linked list itself. Linked list is an input. We never include input space or output space in space complexity. Space complexity means auxiliary data structure, extra data structures which we are creating. So that is nothing, constant extra space. So with that, we are done with the second milestone, that is actually finalizing the approach using a linear search algorithm. Now we will be writing the instruction manual in the milestone number 3. So first of all, let's initialize a node, a list node, current starting as head. We will travel the current pointer, we will make the current pointer travel on the linked list till the point 1, till the point either the target is found or the target is not found and the complete linked list is searched, that is unsuccessful search. So in the loop, what we have to provide? Should we provide the successful search scenario? No, successful search scenario can only be checked if data is compared. So we can't compare data if we are not sure whether node is null or not. What do you mean by that? If let's say node is null, can you get null dot data? No. If node is not null, then only you can get the data. So better will be first check for whether the node is null or not. So we will run the run a while loop only until we can say the current pointer is not null node. As soon as it reaches null, we have to stop. If it is not null, now we can actually check whether it is equal to the target or not. So if the current nodes data, currents data is equal to target, then what we have to do is target is nothing but X. What we have to do is we have to say return true. Yes, found, target found, linear search successful. But if target is not found at the current node, let's go to the next node. By instead of doing index plus plus, what should we do? We actually should basically go to the next node by jumping the current pointer as the current's next pointer, current's next node. So current should be updated as set current as what? Set current as current's next node. So current's next node. But if this while loop runs entirely and the current pointer reaches null in null node, what we have to return? If the current is reaching null, it means target was never found. And if target is never found, outside the loop, after the loop, we will say return false, target not found. This is target not found scenario, unsuccessful search scenario. So a simple enough instruction manual with 4 or 5 lines of code, that's it. Once you know the approach, once you know the instruction manual, each line by line, then we can easily code it in your preferred programming language. Right now, we are choosing Java to code it. So what we are going to do is, first of all, we are going to use a pointer to iterate on the linked list. So pointer name can be anything. I am naming it as current pointer, starting it as head. So we will be starting the iteration from the head node only because we have to always travel in the forward direction. We only have to travel till the point current is not null. So current not equal to null, only till that point we have to run the for loop, because if current reaches null, we cannot compare the data. If this loop ends, finally, we can say return something. So for now, just let's return false, because it is mentioned also that if the loop ends, it means current reaches null. And if current reaches null, the target is not found. So return false. Let's also just run this code before writing anything inside the while loop. Let's see what will happen actually. It will go into an infinite loop. Why? Because while loop will never terminate. It will always say current is not null. So it will always run the loop, and at one particular point of time, it will go into infinite iteration, or you can say a runtime error. So actually, it is going to give me timeout, or you can say time limit exited. But if I actually go to the next node by jumping the current pointer, making it current.next, let's just check the code by printing the every node's value. System.out.println current.next, or actually current.data. And the variable used is current.val. So data will be val. And let's print in one line only, so that we are able to at least ensure that all the nodes are getting printed, or we are able to run a loop on each and every node. Then the condition for true is very simple. Just we can compare with the data. So 1, 2, 3, 4, 5, that is all the nodes of the linked list are printed. Then obviously we are returning false, and it is also getting printed. So we are able to travel completely easily, but we have to check whether current dot value is equal to the target X, then the target is found, and if target is found, return true. So let's just check now. Now the complete linear search is working. Hopefully it should give me correct output for sample test cases where the target is present. But let's just copy the same test case with the target as 6. Is a 6 present in this linked list? Actually, no. So it should give me false. So let's see if it is giving me false or not. So we have covered the corner case also where the target is not present, unsuccessful search. Let's also do it for one single node. Minimum there will be one node in the linked list. This code will actually work even if there is 0 nodes, because initially head will itself be null. This loop will not run at all because head will be current will be null. So we will stop and we will return false. In empty linked list, you can't find anything. So return false. So it will work for n0, but let's try it for the constraints minimum n value, that is n1. With having, let's say, only one node 10, and let's say the target is also 10. Is a 10 present in a linked list containing only one node with head data is equals to 10? It should give me true actually. Let's see. Yes, true. But what if the target is 20, X is 20? Now it should give me false. So let's see it for the corner cases with only one node in the linked list. It is working. Now let's submit, and it is working for all the test cases, as you can see clearly. In linear time complexity, as linear search takes linear time complexity only, and constant space, no extra space is required, no extra auxiliary data structure we have created within the function. So order of n time, order of 1 space of the linear search in linked list. That was a problem linked list search. I hope now everyone is clear with all the 5 milestones. We will come with a new video, and in new video we will obviously discuss a new problem. Till then, bye bye.